So suppose I want to measure the length of a stick that's moving along at high speed. Let's say it's a meter stick. Well, let's draw a space-time diagram. There's time, there's space, and this stick, as it moves along, is going to trace out front and back a region like this. Now, if I measure along the stick's position axis, those are the tilted axes like these. Along those tilted axes, measuring the front and back at the same time as the stick perceives time, and measuring distance as the stick perceives distance, it'll of course still be 1 meter. But I'm not going to do that. I'm going to measure it as I see it, as I see time, in the rest frame, because I'm watching the stick move by. That means delta t, the time between the events for the stick, is not necessarily 0. I'm looking at 2 times that are at the same time in my rest frame. So this delta t is 0. And I can find a delta x primed. What I find is that the length, as measured in my frame of reference, is contracted. I set this delta t to 0. Move this around to the other side, and my length is this much shorter than the length as the meter stick perceives itself. Notice, however, if I were riding along the meter stick and looking out at someone else, also holding a meter stick, their stick would appear shorter, because they would be the ones moving. Now you may ask, how can they both think the other guy is shorter? The answer is, they have a different sense of time. They're not looking between the same 2 events. They're looking at 2 events that are simultaneous in their own frame of reference. Notice if I wanted to find the difference in time between those 2 events, I'm looking at that and thinking I'm measuring the front and back of the meter stick at the same time, but delta t primed is not 0 in that case. If delta t is 0, then delta t primed is negative v delta x over c squared divided by this factor. In other words, when I'm looking at the 2 ends, they are not simultaneously at those points from his perspective. The same idea is what caused clocks to move slow. Delta tau was the square root of 1 minus v squared over c squared times delta t. Less time passed on the moving clock. This time, the key idea is that these were at the same position in the moving frame of reference, but 2 different positions in the quote-unquote rest frame of reference. These were at the same time in the rest frame of reference, 2 different times in the moving frame of reference.